Hello everyone, welcome to School of Devs, where we help aspiring developers become skilled blockchain experts across different blockchain network and technologies. If that's what you want, don't forget to smash the subscribe button and hit the notification bell. In today's video, we will be learning about the primitive data type in Move, which is the foundational building block of variables and data in Move programming language. By the end of this lesson, you will understand how to declare variable, assign values, and work with boolean and integer in Move. Now, let's get into it. Primitive data types are the basic data type that Moves give us to store and manage simple value. They are the foundation for everything else in your smart contract code. In Move, the main primitive data types are boolean, unsigned integer, and addresses. We will talk about the address in another lesson. But before we explore them, let's learn how to declare variable in Move. To create a variable in Move, we use the keyword let. By default, variables in Move are immutable, which means they cannot be changed once you set them. Now, so let's give an example on how to declare a variable in Move. Use the keyword let, then followed by the variable's name, the name of the variable, then the data type of the variable. We will specify the type, then we will assign a value to it. So this is how we declare a variable in Move. We firstly use the keyword let, followed by the name of the variable, the name that we want to assign to the variable, and then the type, what type of data is the variable going to store, then the value will declare or assign the value to the variable. If we want to have a variable that we can change the value later, we have to use the keyword mute to make it modifiable later on. So example, start with the keyword let, then write the keyword mute, then the name of the variable, then we'll specify the type of data the variable will store, and then we'll assign the value. So adding mute to the variable indicate that the variable can be modified or changed later on. Now let's so we said in writing a variable, we declare the keyword let, followed by the name of the variable, and followed by the data types. We will specify the data types the variable will store, and we'll assign a value to it. Remember, a variable is like a container that holds value. If we declare a variable without the keyword mute, it means that that variable cannot be changed, cannot be modified. Secondly, if we declare a variable and with the keyword mute added to it, it means that the variable can be changed. The value of the variable, the value assigned to the variable can be modified, can be changed. So let's give an example. So we'll say the keyword let, followed by the name of the variable x, then the value assigned to it is boolean. That means it's a boolean data type that we want to store, and the boolean data type is either true or false. So we are assigning the value to it, which is true. We can write let mute y, then the type of variable, type of data the variable will be holding will be unsigned integer of size 8. The value will be 42. So if you look at the variable we've declared now, if you notice that this variable called y, we can change the value later on. We can change the value to something else, so we can modify it, and the compiler will not throw an error. So also you can shadow a variable by redeclaring it. And what does that mean? We can say, for example, you can say let z of a type unsigned integer of size 8, and we assign 42 to it. Then we can redeclare it and say let z. So we want to shadow a variable, we can by redeclaring it and assigning a different type to it. Or instead of using unsigned integer of size 8, we will say unsigned integer of size 16. So we can reassign a value to it. And now this is a completely new variable. Now that we know how to declare a variable in move, now let's talk about the data types that we have, the primitive data types that we have in move. The first one is boolean. Boolean in move are true or false value. So it's either a true or a false value. Now, when declaring a variable, we can specify what types of data that variable will be holding, which we have done earlier on. So we can say let is active. So we assign true. So now if you notice we didn't specify a data type, like we didn't write of type boolean, we just assign a variable to it. Now, why can we do this? We don't usually need to specify the types when it comes to boolean because move can figure it out on its own. So we can say let is pause. So without specifying its data types, move will figure it out what data type it is. So the next data type that can be found in move, the next primitive data type is unsigned integer. And move gives us a variety of unsigned integer types based on sizes. We have size 8, we have size 16, we have size 32, size 64, size 128, and size 256. So these are the different sizes of unsigned integer. Unsigned integer are whole numbers, so they are not a decimal number nor a number with negative sign. So any number that is not a decimal number, any number that doesn't have a negative sign is what we call unsigned integer. So it's just a whole number ranging from 0 to millions, billions. Now let's give an example of unsigned integer. Let's use the keyword let. We want to declare a variable because remember, it's when we are declaring a variable that we can use data types. So we say let small of unsigned integer size of 8 equal to 42 or 48. So let medium of unsigned integer size of 64. We are assigning 1000 to it. Then we say let's rename the variable large. And this is another way we can specify the types. We can cast the types by using 1 to 8. So what we've just done, we're saying that this variable is a variable that stores a data type of unsigned integer of size 8. Then followed by the variable called medium stores a data type of unsigned integer of size 64. Size 8 ranges from 0 to 255. That's the capacity of the variable. It can store values from 0 to 255. Then when we say it's of unsigned integer of size 64, it means that the variable can store higher numbers. Same with when we say it is of size 36. So the higher the size, the larger the number the variable can store. When we are assigning numbers, we can either specify the types like the way we did in this unsigned integer 8. We specify the types then before assigning the value to it. But in this variable called large, we assign the value to it and afterward we specify the types. We can specify the type before assigning value to it, or we can assign the value to it then immediately specify the types. So that's what we did here. Now, when writing a number, when assigning a number to a variable, for example, we name it number, let's say 100. If you notice, we didn't specify the type at all. Now, what we move, we specify a type to it, and by default, it will give it unsigned integer 64. Move will say this, the data type of this number is of unsigned integer of size 64. So size 64 default types that move will specify the number to. Now we can look at casting between types. Casting between types, we can also see it as converting between uh, types, the different sizes in unsigned integer. So we are converting from size 8 to size 16 or size 64 and so on. Now, sometimes you want to do math with different types. In that case, you need to cast one types into another using ask as the keyword. For example, let's say we've declared a variable, we called it x, and we'll say it's of a type unsigned integer of size 8, and we assign a value to it like 57. Then we declare another variable, we name the variable y, and it's of type uint 16, unsigned integer of size 16. Then we want to assign x to it. We can say x as unsigned integer of size 16. Now, what we are doing, we are casting between types. We are casting, so we assign this x to this y and declare that the x is of a type uint 16. But at the very beginning, it was u8 unsigned integer of size 8. But now, when assigning it to the y variable, we declare that it's of size 16. So we converted it to size 16. That's what I mean by casting. We converted it to size 16. Now, let's give another example. Let's say variable z, and we'll assign a value of 16 unsigned integer of size 16. I will specify the types. Then we can say x as, so we are converting x to a size of 16, then plus, then y, then we said y as a size of 16, multiply 2. So this is casting, has to do with converting the types. So initially, when it was declared as unsigned integer of 8, when we are assigning the value, or we are assigning that variable to another variable, we can convert the types from that size of size 8 to size 16. So this is what casting is all about. If you find this video helpful, let me know in the comment below. Don't forget to like and subscribe for more move tutorial. See you in the next video.